This is an introduction to Cabal, supercharged Cabal for me and you. I'm Cryptix, presenting today for Wizard Amigas in Portugal, which, when I look out my window here in Hamburg, I wish I could be there. I'm sure it's much warmer. So, first I will give you an overview of what we're doing today. I will start with an introduction of myself so that you know where I'm coming from, not just geographically, but also what I've been up to in the past, what Cabal actually is, if you're not familiar, how Cabal has been functioning up until now, what the Cabal protocol is, its goals and motivation, a rough outline of what it's composed of, and then we will walk through an example session before wrapping up and outlining future work that needs to be done, some links, some contact info, and since this is the pre-recording, no Q&A probably, but yeah, you will see. So, I'm a kid of the 90s. Like I already said, I grew up in Hamburg, Germany. I studied computer science and engineering and the technical university here for a bit too long until I realized that academia isn't really my cup of tea. But the place and especially the self-organized cafe there basically politicized me to, let's say more leftist thinking of how could we build structures that actually work for the people. And that also led me to this endeavor of how do you do social peer-to-peer. Back then BitTorrent was pretty big, and a few friends and I were wondering how could you do Facebook but without the .com in the middle there, the corporation and all this information and all that. So back then also Go was getting bigger and more popular. That I got enchanted by that. I liked it much more than Java, but also felt more like C. And so I felt like, I have programmable pipes now. I can do all kinds of amazing things. A bit later I came across IPFS, which, if you're not familiar, it's pretty much like BitTorrent, but instead of BitTorrent where you just have single files, you can have directory trees, and that way you can have build directory structures of websites, for instance, and basically reference then by content, and everything is fetched locally, and so you still have it on your computer, even if the, let's say, shitty train Wi-Fi or whatever flunks every 5 minutes, you can still browse the stuff that you have with you and don't even have to care if you have connectivity or not. A bit later, the IPFS crew invited me to Berlin for the DTN. I guess these days you would call them unconference. I think this was like 30, 50 people or so. And Dominic Howe was giving a talk back then there over Secure Scuttlebutt. And the system he came up with pretty much of each person has a feed and you follow the people that you're interested in and you copy their feed. And so you basically have these growing, what you now call, back then also already called append-only logs. So each post is signed and reference the post before, and that way you basically know that you either have the full list or somebody tried to mess you, tried to cheat you by omitting something, so you have consistency, which seemed pretty nice back then. And I made a lot of friends there too. A bunch of lovely people, not just tech wizards, but also, it's too much to know and to mention in an introduction, but let's say Cobley was one of them. Then for quite a while I was working on GoSSB, which was a re-implementation of the JavaScript stack, basically to scratch my own itch of, I like the concepts here, but the implementation in JavaScript seems pretty bonkers to me, to be frank. I think a lot of that came from idealism and the aspiration to also be able to run the SSB stack in the browser, which in retrospective seems like it's what isn't really worth it. But I'm digressing out of my own introduction here, but jumping to basically about 2 years ago, Cobley and some others started working on a new iteration of the protocol, and I gave some pointers to that, then was busy with other stuff and just got involved in Cabal recently again. So what is Cabal, you might be asking? This is Cabal version 5. I think this was around 2019, the date on the file at least, and the dates in the screenshot. So Cabal looks like IRC, I would say, if you're not familiar. It's pretty much like the internet reply chat. So you have channels and you have private messages to people. And a Cabal is pretty much like an IRC server in the sense that a Cabal is composed of multiple channels and the people in them. If you want a more modern take, I guess this might be more up your alley. It's an Electron version of the same system. So yeah, it looks nicer if you don't like the terminal, let's say. It runs, yeah, like I said, it runs an Electron and is available for most platforms without having to hassle with node installs and whatnot. So more of an overview of what Cabal actually is. Again, since it's offline first, you don't really need any servers that host the content. Everything is synchronized between the people in them. Everything is stored locally, similar to IPFS and SSP, as I mentioned before. If you don't have, if you could, yeah, you can browse the messages from years ago on a plane, for instance, if you fetched them before, of course. Cabal can never be. Sorry, let me move the mouse away here. Cabal can never go down or be taken away in a sense, and Cabal is identified by its secret key. This is the URL that usually starts with Cabal : / and its large hexadecimal number, and sharing that with your friends lets them find other members of the Cabal, and then you can exchange the messages in Cabal. Yeah, a bit more background in history. I guess the summary is Cabal is an experimental peer-to-peer community chat platform. The first version of Cabal Desktop Mini, which I haven't found a screenshot of, was published in February 2019, according to the Git history. And the first version of the Cabal client package was published in September 2019. And this was pretty much the reduced API that you basically need to build a client, but then you don't have to deal with like network and database stuff. You can just, yeah, say, give me the messages forward or post to channel X. The initial crew was around Koblé, Kira, and OK Distribute. Kira was working on Kappa Chat at the time, which is also based on append-only logs, and not sure if that was a thing yet. I think it prefigures it a little bit, but I put the links in here, and I will share the slides later too, so that you don't have to type them up. Koblé was inspired by Substack's ChatMash experiment, which is very similar to Cabal, but it didn't have channels. So he thought, yeah, this could be really cool if we had channels, and so this is kind of how they got together and said, yeah, we share this interest, let's build it. Cabal up until Cabal is using a lot of the hypercore stack. If you're not familiar, hypercore is pretty much like a modular Lego pieces, building blocks for peer-to-peer stuff. So it comes with Hyperswarm, which is a connectivity layer, and they can say if you have, yeah, like with Cabal, this shared key, you can access this key value, distributed key value store, which is usually what a DHT is, and to say, hey, I'm here, you can reach me on this IP address, and then you can find other people that also are in this Cabal, and then you can connect to them. And yeah, Hyperdrive is, I think, something like a Dropbox-ish thing, for instance, powered by all this stuff. There's lots of things there. Cabal still syncs all the history if you onboard it. So if you invite somebody to a 10-year-old Cabal, they will have to download all the 10 years of history, which is not ideal. And even though the Hypercore stack supports partial sync, it's not really easy to access it or use it if you don't do it exactly like intended. So it's not as not as modular or flexible as you would hope, let's say. So the bad and the ugly, to pull a little Western reference here, is that syncing everything is bad, as I mentioned, especially if you're on mobile or web. Or a web application. If you give somebody the link and you have to download years of history, that's not really cool if they just want to say hi and maybe exchange some information on a project or whatever. And while the hypercore stack is very modular, it's also very complicated and there's lots of bells and whistles and necks and cronies. That's not the expression. Anyway, yeah, it's very complicated. Thus, this makes it also harder to port to other languages, because even if you just need a subset of it or want to use it in a certain way, that wouldn't be an actual hypercore implementation then, right? So do you actually want to build all of hypercore just because you want to build a Cabal implementation? This is pretty much what made the Cabal crew say, well, we want to have more autonomy over how this stuff functions and how and have actual stewardship over our dependencies, so to speak. Yeah, I hope this joke lands, but yeah, you have it's messy, let's say. So if you just want to fix something and you have to deal with all these dependency trees and actually, that can get pretty frustrating. Apart from stuff like you actually wanting partial sync the way you want it. So let's introduce the Cabal protocol finally. Its goals are, from what I've talked about now, should make sense. It should be fairly easy to implement in any language with minimal dependencies, and it should be general enough to be used across different network transports, which basically means shouldn't care if it's TCP or WebRTC or some other bespoke transport mechanism that we don't even know about yet. The messages that you craft to interact with other nodes shouldn't care about the transport. The protocol should be useful even if you just write a partial implementation of it, and I will come back to that in a bit. And it should be efficient in its use of the network resources by syncing only the relevant subsets of the full dataset, which is the partial replication bit, as well as being compact over the wire. And it should also not be specific to any particular kind of database backend. So this basically means the protocol shouldn't force you to write or have a certain kind of database system. For instance, I'm writing my Erlang implementation right now, assuming that I can do this with SQLite, because I don't want to have to write a database just to have a chat client right now. And if in a year or two I realize, well, this is not really super cool, I can switch this out. Again, this shouldn't be forced upon you already by choices in the protocol. So the motivation, one of the core motivations that, I had a chat with Cobley, Kira, and Glyph on Friday, excuse me, to get a bit more information about the motivation, why they did certain things the way they did. So they mentioned the simpleness and playfulness of implementing an IRC client as one motivation. If you don't know, IRC is pretty much like a text-based line protocol. So you send single lines over TCP, or let's imagine Telnet even, where you have like mostly 3 messages, basically a private message and a join and a leave and some others, but that's about it to start chatting pretty much. And this in turn attracts interesting people. If you don't have to implement 3 layers of stack before you get to the fun bits, people come by and show you, hey, look at this, I implemented it in, I don't know, Brainfuck is maybe a strong example, but imagine you could write this on your graphing calculator and suddenly have a chat client, or your Game Boy, or some Oxen. I'm not sure you're familiar with that, and I don't want to open too many references here, but the simpler the protocol is, the easier it is to implement that, and it makes it easy to do it in a day or 2 or 3. Also, another motivation, deletion is very difficult in an append-only log system. So, as mentioned before, if every post is signed and references the post before, if you start ripping stuff out in the middle, then you can't really verify the log anymore. While initially, for instance, when I was working on Scuttlebutt years ago, I was thinking that, well, if you can't delete posts, that makes people more honest, and they actually say that we'll be sorry if they said something rude, for instance. And, well, that might be naive to that might be very naive. For instance, imagine if you accidentally post your public key, your secret key, or your password to some account, or your personal information like where you live. Saying sorry doesn't really help you then. So having delete in the systems is, and I agree these days for sure, is really important. Now, the simpleness also doesn't force too many choices on you on the implementations. By that, I mean implementing a subset of requests is enough. So you can either, there's some that are basically auxiliary, let's say, so that they help, but they're not really necessary, as well as, excuse me, you can make certain choices of how you implement things. Like, do you request all the posts all the time? That is basically doable in a few minutes once you have the main message types around. But you can make it a bit more complex or smart, let's say, on, well, I requested this post before, I don't have to get it twice, or stuff like, let's bunch up a few hashes before we send out the requests again, to make the round trips a bit more efficient. Yeah. And this is what we want more, right? We want to make our own messes the way we want them. And if you want to make a hammock of network cables, why not do it, right? If it's simple enough, go ahead. Now for the outline of the protocol and the pieces that make it up. The main two ingredients that you need are Blake2B for hashing and the ED 25519 signature scheme for message validation and signature creation. Blake2B is, I'm not actually sure when it was published, but by now you find it even in OpenSSL. So I challenge you to show me which system doesn't have Blake2B hashing. A lot of them do. Now for the actual posts and messages, you basically write posts to certain channels, and you have text messages. These are basically the concrete text messages that contain the message that you write to a channel. A delete post pretty much references another post and says, please delete this. The info post is pretty much right now, I think, the name, but I think it's open to have other fields in there. I don't know, could put an away message there, or I don't know what, different kinds of things that your client might want to show. And lastly, join and leave messages. That should be pretty self-explanatory, but pretty much just announcing, hey, I'm in this channel now, and leave is the opposite. Now the underlying requests to exchange posts are channel time range, channel state, and channel list. Channel list is just a list of channels. Actually, it doesn't return posts. It's just a list of strings that are the names of the channels. The channel state is pretty much everything but but text messages. So you basically see who is in a channel, who joined and left, and you can do stuff like send me the channel state for this channel, but also send me updates in the future. So you basically have like this incoming stream of people joining and leaving as they join and leave. Sorry. The time range request is interesting because you can do stuff like send me all the messages in this channel that were published an hour ago or 2 hours ago, or do certain windows of give me everything that was posted yesterday, stuff like that. And channel time range and channel state, they return you not the posts themselves, but just hashes to them. So you basically have very compact replies on which you can, getting the replies, getting the hashes, the client in the implementation can then decide, do I request them directly? Do I check if they have them before only, or even I think it's open in the implementation that if you send somebody hashes before, you won't send them again, to reduce network traffic again, and leaving it up to the client if they want to request all these posts at once, or if they want to shard that to other clients. etc., etc. This is the simpleness again. Now we will go through an example of a simple session. So let's imagine Alfie joins a Cabal, which he hasn't been before, and somehow connects to B, ignoring how we do transport for a moment. She sends a channel list request to learn which channels exist, and they respond back with a list like, yeah, there are channels, welcome, and jokes, and hello, and dev talk, and memes, and cat pictures, and whatnot. Alfie likes to be funny and writes a post join to jokes, as well as a channel state request for jokes with future set to 1, which is, as I mentioned, means that if other people join, she will also get those state updates then. And B happens to like laughing too, by which I tried to say basically B's client also sends requests for the channels that they're active in. Thus, B also sees Alfie's join now, because they basically opened the channel state requests for the same channel to each other. To not be spammed with the full history, Alfie creates a request for the last day of activity. So the channel time range request basically has a start and an end and a limit, which is the number of hashes that they are returned. So it also is pretty nice because you might not know how much activity there has been in the last week or so. So she gets back a bunch of hashes for posts the client may or may not yet have, and the client can then decide how to handle these posts as mentioned. For instance, you could also build a client where you have like a button which says, yeah, there's more messages, and when you press it, then the client goes out and requests those. Or as I said, you can make up all kinds of schemes of how to shard these hashes to post requests. And that's about it. Wrapping up, the next steps are that Cabal is not yet using Cabal. There is a Cabal CLI version which exists for the adventurers and is pretty helpful if you're writing on an implementation. It's mostly functional from what I know, using TCP right now. And while Cabal can do partial replication already, it's still looking for agnostic transport and discovery mechanisms that are decoupled from Hyperswarm. It's not out of the picture that Cabal might use Hyperswarm, but basically, we're looking for alternatives. And one of them is Tor or I2P, or the more recently announced Veiled project also seems pretty fruitful. What's the word? Promising. Sorry. Coplay is also thinking about working on specifying how subjective moderation could work, which is an interest of him for quite a while too. Of how could you have admin-like moderation functionality that is subjective to you, so that you don't need to ask an admin or for instance to kick somebody because there's a debate or whatever. You would just want to be able to block somebody and be done with it. Finally, wrapping up some links to websites and so on. If you want to get in touch, here's the URL for the public development Cabal. And if you can't get into that for whatever reason, there's also an RSC channel on Libera Chat. Here also is the link for the specification, as well as links to 3 work-in-progress implementations in JavaScript, Rust, and my own Erlang implementation, which I started last week. Yeah, thank you. Thanks for listening.